Hello guys, you are gonna see this list of exercises from Concurrency from Leet Code. This exercise is the 1116 string 0 even odd number. If you look in the exercise, we see the description. We have a function string number that can be called integer parameter and print it to the console. So basically, it's this function from this library function from C++. The function does not have a return, just the action of printing the number with the parameter. It's going to be x, basically. For example, calling print number 7, print 7 to the console. And here you're given of the class 0 even odd number, which is this instance. It has three methods. That every method basically is a thread, A, B, and C. One prints even numbers, another odd numbers, and 0. We have to modify this class, print the series from the thread, so calling the threads that prints the function 0 and the odd number 0 and even number and so on, calculating, having a series in total of 2n. Calls thread function 0, then it will call odd, then it will call even, and it intercalates like that. The example one will be with an input n equals 2, we will be calling 0, then an odd number, then 0, and then 2. Explanation there are three threads being fired sequentially. One of them calls 0, the other calls even, and the other calls odd. That they intercalate like 0, odd, 0, even, and having the correct output finally. Here we have example 2. As follows. And this is a constraint, and it's between 1 and 1000. Starting the exercise here, we're gonna use threads, multi-threads, and also conditionals in order to be able to call the threads in an organized manner with this exercise. We're gonna intercalate in the threads, having a mutex variable and a conditional variable to conditionate multi-threading calls. In the instance, in these attributes, we have the number and we're gonna declare some variables in order to compute this. Here we're gonna start choosing from the 0th thread. We're gonna choose the odd number. So we're gonna start with current with an odd number. So we will call the odd number first, and then we'll exchange this with the even thread. This will be the first approach, and we're gonna create a mutex variable. While a mutex variable, this will acquire a resource and blocks the thread, and then as it waits for the conditional variable, it knows if it can continue the execution or if it should unlock the thread and give it to another thread that is asking for the resource. That resource is going to have a conditional variable that is going to query if it can continue with the execution and keep blocking the thread and continue, or instead unblock it and then give it to another thread requesting the resource. So we're going to start with this mutex, and we're also going to use a conditional variable. We're going to name cd conditional variable. Then we're going to create a enum that we're going to call it turn, that is going to have to define options from 0, odd, even, and we're going to instantiate this enum starting and initializing in 0. In public, here we're going to have function that prints for 0. So for all of these examples, we will be printing n numbers. In 0, we're going to start the counter in 1. And this is going to be equals less or equal to the total of the numbers, increasing one by one. Inside this for loop, we're gonna create a unique lock, so it can manually locks and unblocks the thread. Here, we're gonna use the mutex. There's gonna be a little bit more overhead than using the mutex by itself, but we're gonna be able to use a condition variable with weight to be able to unblock and block and unblock with the constructor and destructor from the class, depending as we're gonna using the resource. So we're using this mutex that is gonna mutually exclude that if a thread is using the resource, then another thread cannot use the same resource. We're gonna condition this with the variables from the num that we created. So we're gonna give the turns using this num and the predicate from this conditional variable. So here we're gonna use the lock, that is this variable that we created. We created a variable lock, and we're gonna put it just in the first argument that we're gonna expecting a lock. Then we're gonna create the predicate, that is how we're gonna condition it. This we're gonna do it by reference, so we can change the element chosen in turn every time, and we're gonna return if turn it's equal to 0. If it's like that, then it's gonna block these resources, it's gonna use it and execute the function. To execute the function, here we're just gonna use from a function that is already provided, the print number here that we have as an argument, and we are going here to print the number 0. So we pass this parameter in this case. This is going to correspond to the first call, and that's why we start like already from 1 and less or equal than n, as we are going to start always the printing with 0, as we can see here. So we want to do it for total number of n. Like this case for 5, here we're gonna call 0 5 times in total. So we can see, for example, 1 0 here, the next 0 here, the next 0 here, the next 0 here, the next 0 here, which so we call it the total number of n in the end variables. And here, as this is the starting point, in turn, we're going to pass to the conditional variable either the even or odd thread call. So here we're going to do the calculation in this counter. We're going to choose if it's going to be an odd or even number. As we can see, we started from 1, we end if it's less or equal than n. So we call it in total n times, so starting from 1. In this case, this call is for sure. If this is not conditionated, we have to start always from 0. This is not the case from odd or even, that we have to intercalate or first call odd and then even. In this case, as we're going to start with 1, we're going to start with an odd number. We're going to see that this is uneven. We're going to let this conditional to the side. If it's even, we're going to call odd, else we're going to, sorry, if it is even, we're going to call odd. We're going to declare this turn to odd, else we're going to call it uneven. And we are going to notify all, so the other threads can evaluate in the conditional variable whether they can block and use the thread or they have to wait. Then in the odd execution, same, we're going to create a for loop with the counter starting from 1, this is going to be less or equal than n. We're gonna increase the variable I in steps of 2 starting from 1, so this is gonna make the close being odd, as we can see here. So we are going to call these ones, for example, in this case when n is equal to 2, and we're gonna call the odd number, the odd execution, we're gonna call it 3 times. We're gonna call it the same and not number of times. This is the logic that we're trying from, not number increasing in 2 by 2. And then we're gonna create here our new text variable with a unique log. This variable that is global variable, so this is the variable that is going to create the log, and is going to have the context of the execution, where is the thread being blocked and where is being executed and used. So we're going to condition this execution with wait on the log and the lambda expression with the reference. Now arguments, and returning the turn. In this case, we're going to evaluate if this is odd, in which case it's going to happen. So we're going to be in this specific thread, and we're going to print the odd number, an even number, and same way notify all the other threads. In this case, we print here, we're gonna come back to the execution to the 0 thread here. Why we turn this variable to be 0? As in this case, in this case, we will come back to the execution of the 0 variable, to the 0 thread, as we call even number, and then we call back to 0 until this is terminated. That's the reason here we're coming back, which is to the call of turn on the variable, namely to 0, so we come back to the 0 thread and we notify all the other threads. That's what we are doing here, in a sense. So as we are using this logic of using the nodes to indicate in which case is even, because we are always coming to 0. We're starting from 0. In this case, we're doing the evaluation whether this is odd or even. So we wouldn't need this variable actually, as this would be done all by this logic that always going back to the thread 0. It will decide there inside whether it has to call an odd or even variable. In this case of event, we're going to start from 2, and then we are going to end the end calls, and we are going to increase in steps of 2. So we're going to create the lock. Conditional variable as a log, lambda expression changing by reference. The turn comes from the node, no arguments. Turn, we change it to even. We're evaluating the predicate if we should be in this thread or not. That's what we will be doing, and this will be given by this logic here. That this is a variable that is part of the class, an attribute of the class. Then bring the number, the even number in this case. We will change the execution to 0. We will notify all. This would be the solution of the exercise. We're gonna run. There is an error here on the line 7. Oh, we missed destination here. Sign of builder to 0. Here we will notify from here. Here this would be a return statement. The level of this. Here we have the two returns, and that's the type of here. Be it. And all number. And this would be the function should bring number. From here, which will be number. And we pass the exercise. Solution. Here we have our solution in the runtime. In the memory. Thank you so much.